Introduction to Matrices. Welcome back to our linear algebra course. In the previous lesson, we studied vectors and vector operations. Today, we'll begin one of the most important topics in linear algebra, matrices. Matrices are used everywhere, from artificial intelligence and robotics to computer graphics, engineering, and data science. They help us organize information and solve complex problems efficiently. By the end of this lesson, you'll understand what a matrix is, how it is represented, its different types, and why matrices are essential in mathematics and modern technology. What is a matrix? A matrix is a rectangular arrangement of numbers, symbols, or expressions organized into rows and columns. Matrices are usually represented by capital letters such as A, B, or C. Each individual entry inside a matrix is called an element and is written as Aij, where I represents the row number and J represents the column number. Types of matrices. Now let's briefly discuss the common types of matrices. A row matrix has only one row. A column matrix has only one column. A rectangular matrix has a different number of rows and columns. A square matrix has an equal number of rows and columns. An upper triangular matrix has all entries below the main diagonal equal to 0. A lower triangular matrix has all entries above the main diagonal equal to 0. A diagonal matrix has all off-diagonal entries equal to 0. A scalar matrix is a diagonal matrix in which all diagonal entries are equal. A null or zero matrix contains only zeros. An identity matrix has ones on the main diagonal and zeros everywhere else. These are the fundamental matrix types that you'll use throughout linear algebra. Why do we need matrices? You may wonder why matrices are so important. Matrices help us organize and store large amounts of data in a structured way. They are used to solve systems of linear equations, perform geometric transformations, analyze scientific data, and process digital images. Matrices also play a major role in artificial intelligence, machine learning, robotics, computer graphics, engineering, economics, and physics. Many technologies we use every day rely on matrix calculations behind the scenes. Practice questions. Now it's your turn. Pause the video and try solving these questions on your own. Find the order of the given matrices. Identify the row and column numbers. Determine the type of each matrix. Find elements such as a 2, 3, B1, 2, or C1, 4. Write the order of the given row and column matrices. Finally, identify the requested elements from the matrices provided. Take your time and solve them before checking your answers. Practicing these questions will strengthen your understanding of matrices. Important notes. Before we finish, here are a few important concepts every student should remember. A common misconception is that only a column is called a vector. In fact, every single row or every single column of a matrix can be considered a vector, depending on the context. Always remember that the order of a matrix is written as rows times columns. Also, the notation Aij means the element located in the ith row and jth column. Two matrices are equal only if they have the same order and all corresponding elements are equal. The identity matrix contains ones on the main diagonal, while the zero matrix contains only zeros. These concepts will be used repeatedly in future lessons. Summary. Let's quickly review what we've learned today. A matrix is a rectangular arrangement of numbers organized into rows and columns. We learned about the most common matrix types, including row, column, rectangular, square, upper triangular, lower triangular, diagonal, scalar, null, and identity matrices. We also learned how to determine the order of a matrix, identify its elements, and understand why matrices are important in mathematics and real-world applications. With this foundation, you're ready to study matrix operations in the next lesson. Thank you for watching Lesson 4, Introduction to Matrices. If you found this lesson helpful, please like, share, and subscribe to the hidden world of numbers. In our next lesson, we'll explore matrix operations, including matrix addition, subtraction, scalar multiplication, and matrix multiplication, with step-by-step solved examples. See you in the next lesson.